Hello, this is Tyler Beamer, math instructor, Haywood Community College. This is an instructional video for Math 152 in regards to the Chapter 10 Excel template I created. That template is posted to Moodle under Chapter 10. It is located here. You can use this template for both sections 2 and 3. If you open the template, it looks like this, where you will put the paired data from your problems here in the highlighted section. You have a scatter plot that will then be created once you put the data in. You will have the linear correlation coefficient R calculated, the number of ordered pairs, the degrees of freedom, which is n minus 2, the test statistic that comes from doing a p-value hypothesis test for linear correlation. Here's the test statistic that we're using. It's a t-test, so it's off of the t-distribution. Here's the null hypothesis. Rho is equal to 0, which implies that there is no linear correlation, and the alternative is rho is not equal to 0, so there is a linear correlation where the true population correlation coefficient is either close to 1, which implies there's a positive linear correlation, or close to -1, which implies there is a negative linear correlation. Alright, so let's use number 7 from the Chapter 10 Section 2 homework as a reference. So here's the paired data, and it says construct a scatter plot, find the value of linear correlation coefficient R, and find the p-value using alpha 0.05. Is there sufficient evidence to conclude that there is a linear correlation between limit imports and crash fatalities? So first thing, identify the null and the alternative hypothesis. So since we're doing a linear correlation t-test, the null and alternative hypothesis here are not going to change. It's pretty much always going to be answer D, where the null is rho is equal to 0, which implies there's no linear correlation, and then we're trying to prove otherwise with the alternative hypothesis that rho is not equal to 0. Okay, so then construct a scatter plot. So let's copy this data into our template. So if you click on the little blue tab here, you can open this data in Excel, and it will open in a new spreadsheet. And so what you want to do is go to the template, take out the data that's there, go to the data from your problem, and simply copy and paste that data into the template. Be sure to keep the data paired, and you don't need to copy X and Y again. It's already in the template. And so when you do that, you should automatically get a scatter plot that's created for you. You should also get the linear correlation and the value of your test, hypothesis test. Alright, so let's go to the problem here. So let's match up the graph from what we have in our scatter plot. So it definitely looks like we have some type of negative linear correlation here. So let's match up the correct graph. So it's obviously not A, B, or D. So it looks like we've got C. And it asks us for the linear correlation coefficient R. That is located here. And it says round to, I think, 3 decimal places. So negative 0.966. Okay. It asks for the test statistic, which is located here. And let's see what it wants us to round to. 3 decimal places as well. So negative 6.446. Then it asks for the p-value. And so notice that you are given 2 p-values here, and you want to use whichever one is associated with the sign of the test statistic. So you would use this p-value if the test statistic was positive. You use this p-value if the test statistic is negative. So in this case, the test statistic is negative. So we want to use this p-value here. So let's go back and see what it wants us to round to. 3 decimal places once again. So 0.008. Alright, and then this is a hypothesis test. So we have to draw a conclusion based off of the results of our p-value. So we compare the p-value to alpha. Alpha is 0.05. Our p-value is 0.008. So our p-value is less than alpha. So then that would be enough evidence to reject the null hypothesis. So because the p-value is less than the significance level 0.05, there is sufficient evidence to support the claim that there is a linear correlation between limit imports and crash fatality rates at the significance level of 0.05. And then do the results suggest that imported lemons cause car fatalities? So let's read these carefully. So the results suggest that an increase in imported lemons cause an increase in car fatalities. So let's look at our scatter plot here. So we're graphing the lemon imports as X, crash fatalities as Y. And you could look at the data that was copied into your Excel template. So lemon imports X, crash fatalities Y. So now let's look at our scatter plot. So as lemon imports increase, right, crash fatalities decrease. That's what we're seeing here in our scatter plot. Since we have a negative linear correlation. So the results suggest that an increase in imported lemons causes an increase in car fatality rates. So that would not be it. The results suggest that an increase in imported lemons causes car fatality rates to remain the same. That's not true. The results suggest that imported lemons cause car fatalities. That's not true. The results do not suggest any cause-effect relationship between the two variables. That's a tricky one here. Since it's definitely not A, it's definitely not B. It's definitely not C, because our data has a negative linear correlation, right? So what we are suggesting through the data is that as lemon imports increase, car crash fatalities actually decrease, right? Since we have a negative linear correlation, our line is going down here, right? Our R value is negative. So by process of elimination, I'm going to eliminate A, B, and C. I'm going to choose D. Let's see what happens. Excellent. And in reality, right, you would want to remember that correlation does not always imply causation, right? So even though there is a correlation here between lemon imports and car crash fatality rates, there is definitely no cause and effect relationship here, right? So that's what D is implying. It would be ridiculous to assume that importing lemons is somehow going to make us all safer when driving our vehicles. So just because these two pieces of data are correlated does not suggest that there's any cause and effect relationship. So that's what D is implying here. Alright, so hopefully you find this template helpful when doing these calculations for sections 2. If you have any questions on using the template itself, please email me those questions. Alright, thank you. Have a great day.